Alright, so we are going to talk about taking the inverse of a 3 by 3 matrix using only determinants. Now the first step is if we are given some matrix A, we first want to see if the determinant is 0 or not, because if it's 0, then we don't have an inverse. And if you look at our matrix A, you can see based on the steps we've written right below it that if you do take the determinant of it, you get 138, which means that there is in fact an inverse.
Okay, so then after determining that there is an inverse, what we want to do is we want to take the cofactor matrix of A. So since this is our matrix A, you can see that once we take the cofactor matrix, for example, if you have a column 1, a row 1, column 1, the cofactor of A11 will be 0 times 0 minus 9 times 6, which is negative 54. And then for the second one, you can do 2 times 0, which is 0 minus 27. But then you also want to make sure that there's a negative in front, which makes that positive 27. And you're going to do that so on for all of the other entries so that you get this matrix right here as your cofactor matrix for your matrix A.
The next step is to find the adjoint of the matrix, and the adjoint of the matrix is equal to the transpose of the cofactor matrix. So the idea behind the transpose is the rows become columns and the columns become rows without changing the sign. So as you can see, the first row over here becomes the first column over here, the second row over here becomes the second column over here, and the third row over here becomes the third column over here. The next step is finding A inverse using the adjoint of A and the determinant of A, where A inverse is equal to adjoint A divided by the determinant of A. So what we've done in our next step is divide each entry of the adjoint of A by our determinant 138, and in the next step we've reduced the fraction to the simplest form to get A inverse.